Hi, welcome to the Air Manager API tutorial video series. In this video we're going to be looking at XPL dataref write or Xplain dataref write. So here I am on the Wiki API page for XPL dataref write. So we're just going to have a quick look at the structure of the function. So it's just the one function, the XPL underscore dataref underscore write is the name of the function, and then you see these arguments here which are listed out in the arguments table here. So the first argument that you use with this function is the dataref itself. So we've looked at datarefs previously, and that is the long name of the Xplain dataref that needs to go into that particular slot. Then following the dataref is the type. So the type will be, again, we've looked at this previously, int or an int with an array type, or float, or the different types of data that you can or that the information is contained within the sim itself. So you can see there's the different types here: the int, float, double byte, string, etc., and the array versions of those particular data types. So you need to specify the type. The value that you want to write. So in its basic form, this particular function only uses those three arguments: the dataref, the type, and the value. You can see these other two, the offset and the false, are optional, so you don't have to use them. So we're going to look at some examples of just the basic type and then with the optional elements on the end. So the value is the value you want to write to the whatever the dataref is that you particularly want. So it will depend on what it is as to what data you can actually write to that particular dataref. And then these other two arguments, one of them is offset. That is applies to when you're using it with arrays. So you can say, for instance, say that you want to start writing at a particular element within the array rather than starting at the beginning. So that's where offset comes into play. And then false comes into play where you want to continually write the dataref value to the sim so that it can't be overridden in any way. So it writes to every sim frame if you use the false set to true. But again, we'll demonstrate that and you'll see what effect that actually has. So just before we delve into the code window, a couple of things just to point out in terms of places to go and look for datarefs. One of the locations is if you open Air Manager itself, on this little simulator data button on the end of the top ribbon here along the top. You click on that and you get a drop down of all the different references here for the different sims. And you can see for Xplain, you can look at the datarefs or look at the commands. So if you click on that Xplain datarefs item there in the list, it brings you to this page here, which is a list of all the Xplain datarefs in a searchable form. So you've got all these fields along the top here that you can populate with search terms, and then click search and it will narrow your search down in this big list here, and it gives you an idea of what the particular dataref name is, what the type is, whether it's writable or not, yes or no in that column, and the type of units that the data that's contained within that dataref. So it's handy for when you're doing the development of an instrument to know what that data is actually in terms of units. And then just a brief description of what that is, although most of them are fairly self-explanatory. So that's a source of dataref information. One of the other sources is within the sim itself. So if you have and if you haven't, I urge you to go and get the plugins for either dataref editor or dataref tool, or both, as I've got here. Dataref editor was the older one, and dataref tool is the newer version. Enables you to sort and find and search, and this particular one, the newer one, is very handy in so much as that when you change a dataref, it highlights here for a few seconds and then gradually fades back to white again. So you can see when you're having an effect on some of the controls or switches or whatever it is within the sim, you can see which ones are changing and which ones are not, and you can narrow the search down by putting a term down in this little search bar here, which can narrow the search down so you don't get so many, because there literally are thousands of datarefs. So there's another handy place to go looking for datarefs. So that is essentially the function then in terms of the different arguments. We're going to look at, there's some examples here on the wiki which you can have a look at, but we're going to just delve into the code window now and have a little look. Let's close the sim for the minute, we don't need that open. So the example we've got set up here initially is just to write a standard int, and we're going to write to the COM1 standby frequency, and that's in hertz. So we need to the format of that particular dataref is you give it this full long int value without any decimal points in there. So it's actually, the way the format works out is that it actually equates to 120.15 megahertz with that number that I have there. So the first 3 digits are your hundreds, tens and units of megahertz, and then they're your kilohertz, the last 2 digits. So you can see quite easy to write a frequency. So what we're going to do is, if we open the sim up and we run that, we don't need to worry about this instruction. That's for me to explain to you something for the next one in a minute, but it's not going to have any effect on running with the sim here at the moment. So if we just open the Air Manager window for a minute, we're not going to run our instrument just yet. So you can see I've got the pop-up GPS here, so we can look at the frequencies, get them a little bit larger here. So you can see at the moment the COM1 standby frequency is set to 133 let's move that over there a little bit, 0.45. And so what we're going to do is we're going to run our instrument now, and we should see that change to, let's remind ourselves what we had it set to, 120.15. Oops. So as I press play there, immediately you see it change to 120.15. Now that's just a write one thing. So once Air Manager sends the command, after that write is completed, you're free to change the frequency again. As you can see here, I'm able to change the smaller and the larger numbers there on the frequency quite easily. Okay, so going back to our code window then, that's fairly straightforward, a simple write of an int. The next example we have here is writing to an array. So again, very similar to the previous example, the only difference being is that now we're writing to an int array, array denoted by the fact that we've got a number here in terms of the size of the array. So it's got 8 elements in the array here. And the type is obviously int 8, and then we're going to write some elements. Now you can see here we've only got 4 elements, so what this essentially will do, it will start writing from the beginning of the array. Now it's important to note that when you're coding in Lua, when it deals with arrays normally starts counting with 1, but because we're talking to Xplane with this particular function, when you refer to the positions of the arrays, you need to use the Xplane convention. So as I've got in the note here, this array uses the Xplane convention and starts counting from 0. So in Xplane, when you go and look at the sim, the dataref values within the sim, with say the dataref editor, like I showed earlier, that is referred, the first element of the array is referred to as location 0. Within Lua code, that location is location 1. So just a little confusing, but something to bear in mind. If you're using the wrong index, it's maybe why you're getting the wrong number back within the code, or you're sending the wrong data if you're using the Lua indexing system on this particular function. You need to remember to use the Xplane convention. So in this example, we're going to write 4 chunks or 4 ints, just 1, 1, 0 and 1 to the first 4 locations. That's as simple as what that does, and it doesn't write anything to the next 4 after that because I haven't told it to, so it'll just write those 4. Nothing much more to say other than that's fairly straightforward. So now what we're going to do is we're going to look at that in a little bit more detail with an example within the sim. So let me just uncomment these. What I've got here, I've kept them commented out so they didn't have an effect on what we were doing earlier with the frequency. So what I've got here is I've got initially a statement that just prints first engine start, just so we can see it appear in the Air Manager console window, and then it will send the command to set the ignition to the start position. 4 is the start position for this particular dataref. But this dataref, you can see it's an array. So in this example, you can see we've just got the curly brackets and the number 4. So we're just going to write one piece of data, and as we've just seen in the previous example, because we've not given it any offset, it's going to start writing at 0. So as I've said there in the comment, position 0, that equates to engine 1. Okay, and then I've set a little timer up here just so it doesn't do it immediately, but after 4,000 milliseconds, so after 4 seconds, it prints a second print statement that says second engine start, and then we write to the same dataref, see, exactly the same, identical, but this time we're going to also write the number 4 in curly brackets, but this time we're going to write to the offset 1. Now, you remember I said to you when I was explaining the last example that the counting system for this particular dataref uses the X-plane convention of starting to count the arrays from 0. So position 1 is actually the second element because it starts counting at 0 and then 1. So position 1 equates to engine 2. Position 0 equates to engine 1. So what that's going to do is that's initially going to start or try to start engine 1, and then 4 seconds later it's going to try and start engine 2. So let's start our default position of these ignition switches in the off position in the sim, and then what we'll do is we'll open Air Manager. We'll just move that out of the way, and then we'll watch what happens. Oh, did we save our instrument? Yes, we did. Okay. So press, and you see it immediately went to start for engine 1, and then a few seconds later well, nothing happened. I don't understand why that was. Let's have a little look. What did we forget to do? Oh, everything looks okay. Let's try that again. Teething problems there. Okay, so right, so all off. We got our 2 prints. You can see there, first engine start, second engine start. So I'm not sure what went wrong there. Let's try it again here. So the first engine start and it's gone over, and it says second engine start, and then you go, it flicked over. So maybe it didn't quite get the command there first. I've got a lot of stuff actually running on this PC at the moment with the video capture software and quite a few programs that are open, so maybe that's having a little bit of effect with that. Okay, so there you see how you can write to the 2 separate arrays, and you see when I wrote to the second one, I was only starting at that offset, the second element, which was offset 1. It only wrote to this switch. It didn't have an effect on the original position. So you can see how you can pick out certain elements within the array and just write to them if you want to, or you can write to several pieces of data, but you don't have to start at 0, you can start at some other element and say you want to write to 2 elements that are together but some way into the array. You can just choose that as an offset and then just give it 2 bits of data and it'll write to the one at the offset and then the one after it. So that's that example. And then the last little example I've got for you that explains the offset is, now we're just going to talk about the last thing that we haven't spoken about, which is the false. So there's no reason why we need to comment those other ones out. So what we've got here now is we're back to the same dataref that we started with, the COM1 standby frequency, where we wrote 120.15. So what we've got here now is we're going to write to the same dataref, but this time we're going to write a different frequency, 135.25, and we're going to use the false parameter, and we're going to set it to true. So you can see here the structure of the function. There's our 3 standard pieces of data that it requires: the name of the dataref, the type, and then what actually we want to send. And then the optional items here are the offset and the false. Now it's important to note that for the false, when you're using the false, what I've found is that if you try to just do the false on the end of the frequency there, because you're not using the offset, as we wouldn't be here with a standard int, Air Manager doesn't like that. So you have to, even though you're not using the offset, you have to just put a bit of dummy data in there and put the comma in there, so it sees that as the offset information, even though it's not using it. And then you put the false on the end. So you need to put the 5 pieces or the 5 different arguments in the statement so it doesn't error. So then the false statement on the end there, we've got it currently set to true. So what that does is, now we've saved, if we rerun now, let's see if we can get that out of the way of the thing. So remember 135.25, let's get rid of that for the minute. So we're currently not on that frequency, we're on 120.15. So when we run the instrument now, you can see immediately it goes to 135.25, which is what we had in our code. But this time, if you remember when we did it last time, it just wrote that once. Now, because we've got that false set to true, it's writing it every simulator frame. So when we go to change it, we can't. We might be commanding for it to change, but Air Manager is every simulator frame is writing back to the sim that it wants 135.25. So for all intents and purposes, it never gets our command of actually clicking it, because Air Manager is continually overwriting what we're trying to command. So that's a way of forcing, hence the name, the number to be what you want it to be. Now this isn't a great example in terms of the frequency, because you probably would want to retain the control within the sim, but there might be some particular data in a dataref that you want to false, and you don't want the sim inadvertently overwriting that data, and so you would use that false argument on the end of the function to actually achieve that. So let's just prove that you can undo it. So leaving the same statement in. So essentially what this now does is, this does, barring the number being different of the frequency, but this does exactly the same as the first statement now, because this obviously does nothing, and false is not telling it to false, so it defaults to false anyway. So that first statement, where we only had the 3 arguments of the name, the type, and the particular data, this does exactly the same as that. So I'll just show that when we change that back to false now, we've saved the instrument and we run Air Manager again, or we run the instrument again, should I say. We've written our 135.25, but we can change it again. So it's not forced anymore. It only did that one initial write, and then you're able to change the controls within the sim, or the sim itself is able to change that dataref, because you're not continually writing it every frame from your Air Manager code. So that's basically XPL dataref write. They're all the different arguments. We've looked at the examples of using each and every one of them. So have a little play with that and see how you get on with it. That, I think, concludes this video. Join me again for another video soon. Thanks.